So if you ever stayed at a severe problem and had no idea where to start, so this video is for you. Today I'm going to teach you the sliding window technique from scratch. By the end, you will be able to recognize it, code it, and apply it to LeetCode problems under a few minutes. Right. So we will be go through some of the problems in this particular video. Right. These are the problem which also came in the contest as well, and the note is that all is in Java, so no prior knowledge is needed except the basic array. Okay, so let's get started. So imagine you have given this array, right? So this is the array, and someone asks you what is the maximum of any three consecutive elements. So the brute force way is to check every possible group of three, right? How? Like you will just simply run three loops, and while calculating you just simply calculate the sum and find the maximum, right? But what's the time complexity? So that's O of n to the power q k, right? Because we are running we are calculating it for that many times, right? And we are executing three times because the value of the k is right now is 3. If the value is k is different, then we are iterating at that many number of times, right? So this is going to be O of n square, you can say, or n cube at this particular point. But sliding window solves this in O of 1. And how it does it? Let's see. So first understand that what's the transition is look like, right? What I'm talking about is like you run a loop. So first you calculate a sum of right. So this is right. I will explain you with the diagrammatically so that it will make more sense. So what we are actually doing is what's the one mistake which we are doing over here, right? So let's understand it properly. So first we have calculated the sum of these three consecutive elements, right? Because that what we want. And what the sum is, the value of sum at this point is 7. It's 5 8, right? So the value of sum is 8, right? And now what we are doing is, right, we are moving our subarray this, and now we are calculating the sum again, right? Now how we are calculating the sum? We are doing 1 plus 5 plus 1, right? So this is going to be 7, right? And at the next point, what we are doing? We are doing the same thing. We are moving right here, and we are doing the same stuff, right? 5 plus 1 plus 3, and if you see, it is 9. What we are doing is we are just we are not utilizing the previously calculated values, right? If you see over here, right, this here we are doing a summation of 5 plus 1 plus 3, right? But we already know sum till this point or till this point, right? But instead of just adding the another value, we are calculating the whole new values and whole new size of the k, right? So this is what we are doing repetitively, which is not that what starting to do. So what we will do, right, I think you got an idea what I'm exactly is talking about. That at every point, let's say I have calculated the sum till this point. So when I was when I have to calculate the next from this particular index, so why I'm running loop from here to here? Because I already calculated the sum till this point. So why not I just simply have to add the another element and exclude the previous element, so that I don't need to start it from over here, right? So this is the one thing which we are doing repetitively. So that's what we are going to reduce over here. So in sliding window, what we do generally, we have the concept of two pointer. So the first pointer is pointing over here, which is denoted by I, and the second pointer is pointing to our last index, which is k minus 1, which is 2, right? So first we calculate the sum at this point, right? And when we're done with this, so when the value of j sorry for that, so when the value of j become 3 at this point, which means now j is pointing to 1, right? So now our new window is going to form. Previously the sum is only this, now the sum is going to be of these elements. The sum we want is going to be of these elements, right? So we already know the sum till this point. We just only need to add this new value. So what we can do, we have to do two things. First, subtract the value from the ith position because it is pointing to our left pointer, and add the new value from the jth index, right? So what I'm talking about and what I'm doing over here, let's say till this point the sum is 8, right? So we know that the sum is 8. Now we have to calculate the sum till this point. So what we can do, we subtract the value at the ith position, add the value of the jth position. So if we subtract the value from ith, then it becomes 6, and when we add again 1, then it becomes 7. So, and if you see, this is what exactly the sum of these particular subarrays look like, right? So this is what we are doing. And make sure when we subtract the value of j, that means that is not a part of our answer, right? What I'm talking about is our first window is 1, 5, right? When we subtracted the value of I, then our window should be different, right? So now it starts from 1, 5, 1. So the value of I should also be changed, so that we will pointing towards the exact indices that we want, right? So this is exactly the idea, right? And there are basically two different type of sliding window. This one which we have discussed, it's called fixed size. I will write over here, fixed size window, right? Here we know what will be the size of the windows look like, right? So this is the fixed size, and the another is variable size, which means we actually don't know the size of the window, but we are calculating the answer. But there is certain condition at the point we are going to stop there, and that is going to be the variable size, right? For example, there is one famous problem, right? So the problem name is like the problem is longest substring without repeating character. What exactly the problem is, let's say you have a string like a b c a b c b, right? And you have to return longest what is happening, so you have to return longest substring without repeating character. So what's the longest substring in this particular string is look like? So if you see, we have to return the longest substring without repeating character. So the longest substring without repeating character is a b c. So this is the answer, and we have to return the size, right? But here you see, we don't know what is the size of the windows look like, but you know one thing, like we know one thing, right? While processing, let's say I need to make sure of two to three things. The first, it should be unique. And I need something to track, right? So that if I saw something which I already saw previously, then that means I reach the window, and this is the only window which I'm going to form. How? Let's see. Let's say I'm iterating over this string. So the first is a, and let's say I have taken a hash set. In hash set, I don't have any character right now, so I put a hash set in a inside hash set. Then the next character is b, then I write b, and then inside the hash set I also put b. Then I move to c, my next character is c. I also put c inside my hash set or hash map, whatever you are using. At the fourth position, I saw a, but you see, I already have a in my hash set, which means it is a duplicate, which indicates that our window is only going to be till this particular point, which means the window size is 3 at this point, right? So what we can do, the same thing what we have done over here is, when we reach our window, we are shrinking the window, right? Because we only here is the requirement that we only want unique elements, and in order to form that, we need to shrink our window so that we will form a new array or new substring that will satisfy our condition. So this is the variable size window approach is look like, where we actually don't know the size, but based on certain conditions, we are actually applying our logics and finding out the size of the substring of the window which will be possible, right? So this is the both of the type. This one is the fix, which is probably easy one. This one is little difficult if you are new to this particular technique, but you will get handy like when you solve a lot of problem. Most of the problem are come from this particular thing, right? So this is the type of both of both of the sliding window technique, right? And before I go ahead, like how to recognize a sliding window problem in a contest, because you see how I actually approach this particular problem, but how you are going to figure out that okay, this is the sliding window problem. So ask a problem, ask yourself 3 questions. What are the questions look like? So the first one is, does the problem involves subarray or substring, right? It either contain this, or does the problem is asking me to add most k or add k distinct, does the problem is include this particular thing as well, right? And so, or maybe like the third is does the problem is asking me for minimum or maximum. If any of the three matches, or maybe like if all of the three matches, then it is 100% going to be a sliding window problem, right? So make sure to recognize this pattern, right? And most of the time you will actually got to know that okay, when you are going to apply it, because these are the standard hints that sliding window fixes, right? So that sliding window, fixed variable and contrast level, all in one video, right? So let's see the code which I have written for a fixed size window. If you see, what I have done over here is I have just created a custom array which I have used over here, and I just taken a value of k as 3, right? I have an array. These are just the edge cases, like when the k is greater than n, there is no sense of iterating because k is already greater than n, right? After that, I'm just calculating the first window because first window is constant, and after that, this is the standard template. You can write it in your notes or wherever you want, because it's a standard template. What we are doing, we already have the sum of k. Now we are excluding the first element and adding the new element, and after doing while doing this, we are calculating the maximum sum. And if you see inside this array, the maximum sum is going to be 9, right? And if you execute this particular code, so this is 9. And talking about the time complexity, which is also O of n, which is more sufficient than O of n cube. So that's sliding window, like fixed variable and contrast level, all in one video. If this helped, subscribe. I post Java solution for LeetCode weekly contest every week on Proof to Code, which is my YouTube channel. Drop a comment which part has hardest to understand. I will reply to everyone, right? And practice these three problem, right? I will write it over here. So the first is LeetCode 643, and then which is the easy one, LeetCode third, which is medium, and LeetCode 76, which is hard. So try to understand it, try to find how we can approach this particular problem while using the sliding window approach. So that's all about this particular technique. And if you're able to understand, do let me know in the comment section. If you have any query, if you want me to explain some more problems while solving and while using this particular technique, so do let me know in the comment section. I would love to make video on that as well. Until that, bye bye, take care, keep grinding, keep learning, and yeah, that's it.